Welcome everyone to a very special program from the ALN and our organizational members, ONUMA Inc. and CDV Systems, who will be talking about harvesting BIM. It is the pleasure of the Asset Leadership Network to have introduced Kimon Onuma and Cyril Verley. They are both architects, trained and licensed, who understood the value of information architecture and have migrated into helping owners solve their architecture information issues. And it has grown from CAD development to building information. They were doing this before there was even a building information model. They were on similar tracks, and both have developed software and are helping owners at different parts of the information management process. And once they met, they realized that their systems work very well together and can provide a solution for owners from concept to decommissioning. And it's something that people have talked about for a long time. And they actually have put together a sample building to demonstrate these possibilities. So it's my pleasure to introduce Kimon Onuma and Cyril Verley.
Thanks, Mike.
Thank you, Mike.
So I guess I'll just start with my portion here. Thanks for having us here. We're going to try and have a little bit of fun today. So it's going to go pretty quickly, but the topic is harvesting BIM to build informed environments. And this is about the entire life cycle. We're going to go end to end. We're obviously going to be skipping over some things pretty quickly, but we want to demonstrate from a life cycle perspective and from an asset management perspective how important it is to think in terms of data flowing from end to end, all the way from the owners through design, construction, and into the digital twin world of managing and maintaining assets for the life cycle. So how does that work? And we want to also think in terms of how do we keep things simple? Because if you think about the entire life cycle, there's a lot of complexity. Like Mike mentioned, both CDV and ONUMA have a long history of working with BIM. On our side, we've been going at it for actually more than 30 years. Even before we were using BIM, we're doing 3D modeling and databases connected to it, and even building entire military bases back in 1993, 94. Using BIM applications. And from then we started building our own applications for our use and for our clients' use. A lot of the groups that we work with are asset owners. We found that as architects, we're interested in working with others in the AEC industry, but we also feel that asset owners have a huge voice in how to maintain and manage assets over the life cycle. So we really think that starting with the asset owner and working with them to get to this digital twin world. How do we think in terms of a single building or entire city, like we talked about earlier about Calgary? How do you look at trees and buildings and all kinds of assets? So if we start from thinking in terms of asset management and total cost of ownership, the owners obviously have the finances and budget to build. They need space and resources for people. They need space is a valuable asset that supports the organization. It's that between the walls, what drives the functionality of the organization, whether it's a city or a college or even a single house for that matter. There's a concept of time. There's a past, things that happened in the past that worked, that didn't work. The future is being predicted in the current state. There are physical assets, equipment that needs to be maintained as one example. We want to look at energy for the life cycle. And we want to look at not only single buildings, but entire portfolio, entire cities or entire regions. The ISO standards are perfect for being able to thread through all of these needs. And the Asset Leadership Network is really leading a lot of this discussions. So if we think about money, for example, and total cost of ownership, I think if you look at your car, how do you actually think in terms of what's the total cost of ownership of operating a car? There's a first cost, the initial cost of buying it. Then there's depreciation, operating cost, fuel, interest, and you start stacking up. You have to think, take all this into account, insurance and maintenance and repair and taxes, and you need to make a decision. Do I go with a gas car? Do I go with a hybrid? to go with electric, or maybe I just walk. So all of these pieces of data, if you had to juggle a bunch of spreadsheets or information manually, it becomes a very complex operation. Luckily, we're very used to thinking in terms of simplicity. All of us have been trained to use mobile devices and ask it questions. What's the value of this car? What should it be? What's the condition of this car? These applications are all around us. They just aren't as common in the asset management and the building industry, and the digital twins are heading in that direction. But that's the opportunity that I see. How do we take the very complex data, make it simple, make it relevant to that user, that specific user? So if that user is an owner, they have a certain understanding of what their assets and needs are, and they can communicate that to the design and construction teams, and then they know what they want to do for operations, how they maintain their assets. We're putting a QR code on the screen because we're going to try and do a quick live exercise next. You can scan this and get to the site. We'll bring this up again later, and you can take a look at what we're going to be. It's about 5 or 6 slides later. We're going to actually go through this exercise. So let's think in terms of an owner's requirements. So what do owners need? This is an actual owner that we're working with. We've presented this. There's another recording of this online on the BIMStorm site, on the ONUMA site, and I think on the ALN site as well too. This is the California Community Colleges. They're the largest community college district in the US and maybe even the world. They have 2.7 million students, 5,000 buildings, 116 campuses. They need to manage spaces. They need to plan for the future. They need to plan for individual projects. They want to do scheduled maintenance. We've connected our database to their database. This is where you get into digital twin territory. We're not importing their data. We're linking to it and say, okay, you as an owner have data that says, here's a building, here's a space, here's an asset piece of equipment, here's information about our students. If we start connecting those pieces together, we start seeing graphically on a map, just like that mobile device that we saw, the pull up the car information. We're pulling up information about the entire state, that campus, that building, that floor, that space, that piece of equipment, that work order, that preventive maintenance, what's going on right now, and then in some instances, even live sensors to show what's the temperature of the space, for example. This is with Build LACCD, is one of the districts that we're working on, and they have 742 buildings out of the 500. So it's the largest within California. And they've implemented a asset management maintenance, a computerized maintenance management system, which is our system called BIM Genie, connected to building information modeling, which is the graphical 3D connected to data that they can visualize and interact with in real time, have the conversation, essentially having a conversation with your data in a familiar way. So for example, they can pull up an app and say, there's something going on in this room. We need to get somebody to fix it, or there's a preventive maintenance schedule that needs to be fixed. And it feeds into other applications to be able to quickly get to it. And if you want to drill into more and more levels of detail, it's all there if you need it. The trick is to keep the right level of balance of how much information do you need to make a decision. And a lot of times it could be just a dashboard, or it could be maybe just a single plan, or maybe it's a plan of an entire campus, or maybe it's a color-coded building that's red that says the system's getting ready to fail, or maybe it's an interface for the custodian, which is Dabblefox on the right. How do you manage your custodians related to space, related to assets? What are the critical spaces that need maintaining if you're looking at preventive maintenance? So there's a lot of complexity, as you can imagine, in the background, but the nonstop goal for us is how do we make that complexity simple so everybody can interact and work with whatever tool they need to get to the information. So how does that work? And I'm involved with the National Institute of Building Sciences, and they manage and maintain a lot of industry standards. They're working on the National BIM Standard version 4, which is coming out, and there's a conference coming up in September. They're working on what's called BIM uses, the different use cases, the BIM execution planning, which is how do you start and track a project, which Cyril will be talking about, and the COBE standard of how do you get assets data from design and construction into facility management systems, because these silos are a constant challenge, and industry organizations like NIBS help make that happen. Through NIBS, we've also worked on another angle for owners. Owners have the need for space, like I mentioned earlier. That space needs a certain size and needs certain kinds of equipment in it. And it's typically very difficult to find that information, even in an architectural firm. There's architects that are more advanced that have a database and have BIM and all that, but we're talking about owners and their standards and communicating it with architects and engineers and builders. And we built this tool over the years and then implemented it for a series of NIBS projects where it's like an Amazon shopping cart. And you can actually try this. I'll walk you through real quickly. And I've shown this before, so I'm not going to spend a lot of time on the demonstration here, but I want to show you what I'm talking about on the tool. So it's a online tool, and like I mentioned, we're going to be focusing on residential for this, but there's healthcare and other types of spaces. There was a question earlier, are these kind of fixed templates? They are, but they're also driven by data. So if the owner says this space is no longer 133 square feet, and we need another chair in the room, the database can actually update it before the Amazon shopping cart builds it. It's on the fly, essentially, that you can say, I want to build a living room. I want a single living room medium here, and I need a dining room. So shopping cart concept. I need a kitchen. We're building up the program for a single, let's say a 2-bedroom apartment. And then you go to the cart here and you say, okay, this is my shopping cart, and I'm going to add this, put my email in here. Do I need to change the quantities? If I want another bedroom, for example, I could say bump that up to 2. So now we have a 3-bedroom apartment. And then I would say build. So that was the goal. In the background, there's a lot of stuff happening. There's a database of all these spaces, all the assets, all the things that are needed. And then it sends me an email that says, now your BIM is ready. Your digital twin, beginning of the digital twin that's going to be fed into what Cyril's going to be showing next, is ready to be viewed and accessed. And you get an email that says, go ahead and download it. So there's a lot more to this, but just conceptually, that's what's happening here. So I'm opening it up, and there's the model now that's going to load in. And you can try this yourself. It's a free tool. You can start editing and keep going to that, but there are the bedrooms. It's a full BIM in the background. If you open this in 3D, you would actually see a 3D model as well too. Okay, so let's keep moving here, because we want to get to some other concepts here. So those 2 concepts I just described, the concept of an owner's programmatic requirements, which are constantly shifting and changing. So if your organization changes, if COVID hits and you no longer need more office space, you need to be able to dial that up and down immediately and stop building more office space, for example, or go and look for renovating space, like was talked about in Calgary. How do we find existing space that can be converted to residential is another example. The other concept is the concept of standards that I talked about. So you standardize your programmatic requirements, and each owner is going to have slightly different programmatic requirements, but having a BIM and a digital twin version of that I just showed you that is driven from a database allows you to maintain and manage a huge amount of standards and data that is tied to the graphics that then you can communicate and make sure things are fitting. And then using those kit of parts essentially that are adjustable, you can call up that space for using it on design. So let's now shift into the next phase for doing quick planning and portfolio management. We're going to show a little bit of the AI work that we did here, because everything I talked about before about go pick the space, go query the database as a user is obviously really powerful, and it has been for us for many years, but now we're starting to layer in, well, maybe AI can help us do some of this. We don't have to manually say 2 bedrooms and 3 bedrooms. You could ask it a question that starts responding to you, so you can get there a lot quicker. You still have to check it, as we know, but we've been testing quite a bit, doing development using the different AI tools. We said, help me plan the life cycle of my portfolio assets, for example. Using those kit of parts that I showed, we want to land 18-story apartment building in Tokyo and see how much it's going to cost. Does it fit? Do we have the right spaces, the right space types? It's in Japan, so the living spaces are a little different than they are here in California, but it's all rule-based that at least gets you within range very quickly. Within a few hours, basically, you can create many versions of this. And then we take those models and start saying, okay, now let's pass it over the fence to the BIM applications, which not pass it, actually we link to it through APIs to be able to do additional design work. So that's where we are with that kind of concept. And what we did with AI, then we said, okay, let's ask it some questions. Can you create some architectural renderings of this and describe that that program that was there, and we wanted to see how close it can get. And you've heard of prompt engineering for AI. It's kind of a how do you talk to the machine? And as architects, both Cyril and I had that experience to be able to use architectural terms to even describe what that space would look like. So for one example is there was a 43-page PDF that says, here's what we require as an owner. We put that PDF into the AI and we start asking it questions. What does this PDF tell us? Well, it tells us you need hotels, you need housing, you need this many square feet, this many units. It started building up a spreadsheet for us with quite a bit of detail that we adjusted. We didn't take it as is. We started having this conversation with the AI, and then started feeding it into our system that I showed earlier to generate the first massing models of the assets with all the equipment in it, and started landing it on the site. And that's how we quickly got to a point where we did a whole portion of the city with AI generated images and say, these are the type of buildings that are going to be there. Does the owner accept those? Do they look the right type? And from there, we can then start even doing engineering analysis. If we have a microgrid, how much energy do we need to support this building? So it still needs more detailed design after this, but you're starting to get closer and closer to an answer to be able to evaluate, are we making the right decision? If we want to go to LEED Platinum, what do we need to consider in this apartment, in this building, in these 18 floors? So it goes very quickly. What I showed with the shopping cart that I manually selected bases, within 1 minute, you can ask the AI a question, say, here are my program requirement data, and not just don't go out on the web, just go to this database that I have, generate the spaces that I need automatically, put them into a model, stack them on the site, and then let's see it in 3D and start generating visualizations from that. So it's a very rapid way of having data that's an asset driven into landing it on a site to be able to simulate different scenarios for a campus, for a housing development, for a lot of different, let's see what happened here. A lot of different building types. And it's not letting me advance for some reason. Oh, there we go. Okay, housing for corporate housing or student housing. What does it look like? This is AI generated image on the right, AI analyzed data on the left, talking to the program to BIM Amazon shopping cart that I showed earlier. AI generated image of the interior of a unit by using prompt architecture to describe it to Midjourney and say, this is what the unit looks like. And it comes pretty close to be able to tell the story. So this is kind of an overview, early planning with early cost. I mean, imagine that total cost of ownership that I showed for a car. This is what it's doing. It's kind of running through scenarios to get us within range to say, are we heading in the right direction? Yes, we are. We want to keep on going now. And this is where we're going to transition now into design, engineering, and documentation, which Cyril is going to walk us through. And we're going to shift screens here. Yeah, time to shift screens. So Cyril, you ready?
Yep, I'm ready.
Okay.
You can see my screen?
Yep. That's
Excellent.
not, yeah,
Okay.
there we go. Yeah.
Perfect. Okay, thank you, Kimon. Let me just, great. Okay, so we're going to jump into design. We want to make this model that's been generated via AI and this program to BIM a real model. So this model, so I'm going to take a step back because, again, our intent here is to create a model that's useful for the owner. And our perspective, of course, is harvesting BIM. So from our perspective, the first step to managing any room or asset is to actually have to locate it. You've got to locate the room, you've got to look at the asset on the level, on the building, on the campus. That's the key. That's the first step in order to manage any asset, regardless of what it is. So the intent here is we're not going to be using BIM. We're not suggesting that BIM be used to manage the facility, but as a tool, the BIM model in an ideal world is the single source of truth of all the rooms and all the data and all the data, the asset of those, the rooms, the list of assets and the data attached to them. That's the key. And in an ideal world, the best people to create those models are the architects, engineers, and contractors. And if we can define within a BIM execution plan how the models are to be built, then these models are data rich for the purpose of harvesting to whatever programs are being used. In this case, we're going to be going to BIM Genie a little bit later in the presentation. So our intent here, and again, I'm going to take a step back here because when we work with owners, we want to make sure that owners understand the broadest view of who can benefit from this data. Space planning in terms of departments within an institution. So obviously space planning, that's low-hanging fruit. Facility management folks, absolutely, it makes sense that they can use this data. Capital planning, different perspective from space planning, but certainly they can benefit from this data. Asset tagging, we've worked on a number of projects where asset tagging is a critical aspect of output from these models. Indoor GIS, one of my favorite features, creating a simple graphic of an entire campus or an entire city within indoor GIS. The real estate department, wayfinding, CMMS, you'll see BIM Genie in a moment. In an ideal world, all of these departments within an institution can benefit from this data. So the key is, in order to really be able to harvest BIM, is the models themselves. So imagine, and we hear this all the time, models receive owners and they get the model from the architect and that model looks great. Then they get the model from the interior designer and that model looks great. They get the model from the civil model. They get models from the MEP folks. They get models from the contractors. And these models are all in different languages. Their data structure is completely different. In an ideal world, what we're looking for is to create a digital environment where the data structure is consistent across all trades from top to bottom, from beginning to end, so that when those models are delivered to the owner, those models are data rich and and thus have the ability of harvesting that information for the benefits of these particular departments within an institution. That's our perspective. So we've been providing, and the solution we have is called Collectus. We've been working as BIM consultants for these remarkable list of clients you see in front of you. On our website, if you click any one of these icons on our BIM client page, it'll send you to a page that describes the services that were provided, whether it's training or implementation or modeling services. What we've created as a result of 20 years of experience working with these amazing firms is a facility owner's library with an integrated BIM execution plan. And the intent here is that the AEC teams would use this library to build their models. It's made up of 36,000 components across all trades, and it includes the data structure that the owner wants in order to harvest the data. And again, this represents our 20 years of working with amazing firms like HOK, SOM, MBBJ, AECOM, Denver International Airport. So in terms of Collectus, the first step here is to define the BIM data. BIM execution plan, great way of doing it. We like to incorporate the data that goes along with it. And that data includes standards from standard BIM execution plans and also data from COBE. Okay. So here, for example, we're going to get a glimpse of our BIM execution plan. This is the cover page for the Tokyo project we recently did with Kimon. It's a standard form to fill out, but then you get into the data section. Now, this is part of the BIM execution plan. And we use this terminology called LOD 3, 4, and 500. Now, please don't misunderstand the term LOD. Don't think of it as modeling to an LOD 3, 4, and 500. We don't agree with that. Modeling to roughly LOD 300 to 350, if you're familiar with the LOD term, level of development, level of design, level of detail, there's different ways of describing LOD. It has to do with modeling. From our perspective, we're describing the data inside the models. So we keep the models light, LOD 300 to 350, but the data behind it is dramatic. So for example, the LOD 300, that's the data requirements, the parameter lists that the MEP engineers would fill in. And if they were to look at these parameters, they think these are perfectly fine, perfectly legitimate. They have to provide that anyway. Then we have LOD 400, which is manufacturer data. We call it as-built data. This is for the subcontractor or the contractor who's installing this air handling unit, as an example, that they have to fill in this data. Again, they have to provide this anyway. They'll look at the list and they'll recognize these requirements. It's nothing beyond what they're supposed to be doing. And then we have LOD 500, digital twin record model data. Again, this is to be filled in by the contractor or subcontractor installing these air handling units. Again, it's not beyond their scope. It's simply a requirement that's in the BIM execution plan. Now, the next step is part of the BIMX plan just defines the requirements, graphically with images. And we have these diagrams that describe activities from pre-design to operations, and who's responsible for doing certain activities through all the phases of the work. And further downstream, there's a diagram that describes for the contractor or subcontractor, they have requirements for post-construction to create these models that have an LOD 4 and 500 values, and that for the intention to harvest the data. Hopefully the image that you have here is not blocking what I'm showing, because I can see that it's blocking. Oh, there we go. It's a responsibility of the general contractor or the subcontractor to provide that model. And of course, the intention is we want to take that digital twin model and we want to expose it to, in this case, BIM Genie, for a variety of needs from a CMMS perspective. Okay. So in terms of Collectus, the second step is to provide the library, provide the data. So here we want to make sure that that when these models are being built, the AEC consultant teams have everything that they need to build the models from the cloud. And if they want to make new content, they can do that too. The data structure is already there. So if we were to look at, this is actual images from when we received the output from ONUMA Systems in the program of this 18-story high-rise tower. The export came in, it came into Revit looking like this. And we then started adding in, to make it real, we started adding in the Collectus content. So Collectus is an icon inside of Revit. We want to choose, in this case, we want to choose, there's the BIM Execution Plan. If they want to actually view the BIM Execution Plan inside Revit, we can do that. If they want to start loading content, so we're going to load system families like walls. And this project was in metric, so you see metric here, but of course it's imperial too. We drop the walls in, and these walls have data that's included in the BIM Execution Plan, and those same parameters exist inside the walls themselves, so that they can be filled in by the contractor or subcontractor building these walls. Likewise with doors, we're loading doors now. This is where the list of 36,000 components across all trades, everything's based on master format within Collectus. We'll talk about the conversion from master format to OmniClass and uniformat a little bit later. That's part of Collectus. We're dropping in some doors here. Of course, they're in metric, and those are placed into the model. They too have the data structure. We then want to drop in floor elements from the pallets inside Collectus. Again, we're dropping in these pallets. Again, this is not Revit out of the box. These are our 20 years of experience with best practice workflows of building content. Here we have components coming from life safety, coming from lighting fixtures within the library. Again, those are populated in the models. And then with ceilings, of course, plumbing fixtures, and system families like ducting and piping, and again, here we have these kinds of graphics that are part of the package themselves. We're sensitive to how these connections and these systems work. And of course, we have the mechanical components as well, with their ducts as well as system families, component families, system families. And there again, we're dropping these into the models themselves. And these are all, of course, they're all linked models. So these are some examples of some of the models that were converted from ONUMA Systems into real Revit models for the purposes of now tracking the data, entering the data, and massaging the design as well. There were some changes that we discovered in this process that required some design changes to these layouts. Perfectly normal as part of the design process. Once we get to the end, we then want to be able to validate. Now, again, the BIM Execution Plan has a list of all the parameters that are required. The owner needs a simple mechanism to check the models for compliance, not to be Revit experts, simply a way to check them. So within the Collectus database, different place to drop in the schedules, there are schedules for LOD 300 for the MEP schedules that can be that are in the database, or the mechanical schedules that are in the database, or plumbing schedules that are in the database. So these schedules mimic the list of parameters inside the BIM Execution Plan. The teams don't have to make any parameters. They already exist, ready to go. Likewise, LOD 400 for the contractors and subcontractors, they drop in these same list of schedules. They too have the same matching parameter structure as the BIM Execution Plan. Nothing to build, simply to place these elements and fill it out. And again, Collectus allows a mechanism to create new content if they want. There's a whole variety of family templates to create new content that already includes the data structure. So of course, here we went from what ONUMA Systems delivered to what we delivered in Revit via Collectus. And again, there's some examples of this. So the turnaround was actually was quite quick. Next is to take this information and pass it over. So here again, we've got these models, and we're looking at, if I click on an air handling unit here, this air handling unit you see right here is that unit right here. You can see the parameters that exist here. You can see that these are instance parameters, these are type parameters. Again, they match exactly with what's in the BIM execution plan. And the next step is to take those same from ONUMA Systems to harvest that not only the list of parameters, but the actual data inside of it. So it's a one-to-one match between what's in the Revit model and now getting pushed into ONUMA Systems. And now I'm going to pass it back to Kimon for the BIM Genie side, which is, for me, very exciting. Kimon, I'll pass it back to you.
Great. Thanks, Cyril.
You're welcome.
That was fantastic. Yeah, a couple of things that I think are important to note here. This was our first time working together on a building together, right? And
Right.
Through ALN, we were introduced just a few months ago, but we actually started this work. Probably the total was about not even a week, and it wasn't even really full time. And yeah, and the reason it worked, I think, is because we're using open data, we're using a common standard, we're using open standards, and we're speaking the same language. And there's simple connections. There's a lot of complexity in the background, like we mentioned, and that's a very important point. The tolerance for doing something too complex, we would never been able to do it if it took too long. But because it was easy to do. Let's see, which slide did you end up on? I forgot now.
That's the one.
I guess you ended up here. Is it this one?
No, it's the number 5, the 5 bubbles.
You showed this. Yeah. Okay, great.
Yeah, we saw that.
So yeah. So all this data that you showed earlier in your last slide, basically, some of it came from the owner requirements, like the furniture and equipment. There's, I don't know, 4,000 or 5,000 pieces of equipment, furniture, FF&E, and then you added additional mechanical systems, which were based on, for example, we had attributes in the space that says this space needs to be whatever, 75 degrees in summer or whatever. So you're basically engineering it and giving it back, but the alignment with the IDs stayed constant, which means all of a sudden we're in immediate alignment from a standards perspective, which is why it flows into CMS easily. And this is a critical point because we've seen this over and over in the industry. The big break point is when the design and construction is done to get it into CMS systems, sometimes takes a year or a year and a half or whatever. And there should be no reason for that. At least agreement that the owner has to drive this. The owner has to say, I need data in a format that comes back into my CMS system so I can use it on day 0 that I move in, which is what we're going to walk into next. Do you agree with that? I think we've had the similar experience with the owners that struggle with this. And
absolutely.
And this is a lesson learned for us, but I think it's also for the industry because it's really about using open data and open standards to communicate between systems. There's nothing really, it is magical, but it shouldn't be magical. It's like our expectation of using mobile devices. So that's what we'll show next. So I'm switching kind of the roles here, and I'm going to be put on the hat of the owner now. I started as the owner saying, here are my programmatic requirements. Here's our standards. Here's everything. Here's our spaces. Now I'm getting the data back, the harvested data from Collectus and Revit and all the other tools that you used back into facility management and operations. So what does that look like? We're in digital, we have been in digital twin territory the whole time, I think, because we're doing live connections back and forth as we're simulating that development, getting closer to actually building it. Now we're building it. Now we're transferring it to the owner. And we're going to do a live exercise. I'll bring up this QR code again too, but you'll see how you can access this building that we showed that was developed in real time through the web. So this is a building that Cyril showed. As an owner, I don't have access to Revit, but I can have access to tools, for example, that are, it's pretty interesting. This is an Autodesk tool that you can actually see. Let's see. Let's open it up. There it is. I got too many windows open. So this is a full model that Cyril was showing, but it's in a browser that works even even works on an iPhone for that matter. But it's everything inside the building. including, if I go inside it, the furniture and equipment. And if I touch on one of these pieces of equipment, it has data that came from the requirements initially, and then the additional data that was added from Collectus would be, if there's a mechanical system in here, it would actually start showing up here. So that's an important point. You end up with a digital twin model, essentially, of the as-built condition with IDs that are matching everything that I'm going to be using to run through the scenario planning that we're going to be doing. I mean, the work order and CMMS that we're going to be showing next. So that's one thing. What Cyril mentioned on the transfer from the ONUMA system into Collectus, the additional data added in Collectus, the IDs matching up with thousands and thousands of rows and literally many, many other attributes. So it's tens of thousands, if not, I don't know, sometimes it goes up to 1 million pretty quickly, I think, right, Cyril, if you get a larger building like this. And with that, so how do you actually access that on a mobile device? Just like we showed getting, finding the price of a Ford, it should be the same access point. It shouldn't be difficult to say there's something going on in this room, which is the end user, the technician in the field or the occupant, to be able to say, my room is hot. That room knows that the system that controls that room, that apartment on the 5th floor is sitting on the roof. That roof is connected to data relating to that system, so you can maintain and manage it. That's conceptually, that's what this is all about. All of these decisions are made through design and construction, but typically they are lost on handover. So the harvesting of the data does not happen. So that's the opportunity here. At the same time as other systems come into play. So if there are sensors attached to the piece of equipment and we align the IDs of that sensor to that equipment, this is where digital twin territory starts coming up too. You're getting live interaction between a physical building, the physical asset, the actual building, and a digital representation of it in real time as people are in the building complaining about the temperature being hot, as a sensor saying it's reached this particular point and it's triggered a response to be able to get back to the technician. So this is what it looks like. We'll show this live in a second, but our interface is called BIM Genie. It's been driven by every single client that we worked with, saying that they've had challenges of getting to the data about their facilities, their digital twins, their buildings. How do we get to a simple interface? So we created a simple interface, pretty much zero training. Pick it up like a mobile device, find your building, point to the floor, point to the space, tell us what's going on. My condo is hot and I hear a noise in the ceiling. This is the occupant in that room. They have no idea about the systems. They just know it's hot. Technician gets alerted. The technician opens up their app in the field. They see the request, they see the location, they see the ID. They can point to the room and say, oh, it might be the air handling unit in the ceiling, which has all the data because Collectus collected it, harvested it during design and construction. So now the technician has the exact same information, warranty information, click, pull down the PDF, all in the palm of their hand. So that's two different users here, but they're communicating. So all of this in digital twin world is about communication between systems and systems, people and systems, people and people, different applications that don't typically work with each other should be able to communicate to each other. And now let's try this live. You can try this, you can follow along, but I could show you this just quickly. This is a QR code, the URL, you can try this later, but go ahead and submit a work request. This is the exercise that we're going to do now. It's going to take a minute or two. So let's go through that. So if you scan the QR code, you'll get to this. It's bimstorm.com/live. It's the live version of the model that Cyril showed earlier that we looked at here on the right. We don't have to look at the detailed BIM. That's nice to have, but here we're just trying to get to the building. So the way that we get to the building, you have a GIS view of the whole world, but it's zoomed in on Calgary because we've landed it in Calgary. We moved it from Tokyo to Calgary for the presentation today. And you click on the building, it pulls up the name of the building, and then it says, okay, you're on the 1st floor. Let's go to the 5th floor, because this is what Cyril was looking at earlier in his interface. On the 5th floor, I have a unit on the 5th floor that the air conditioner is not working in. It's in this laundry room or this dining room. When I click on the screen here, it has an ID in the background. These are where standards kick in, all the COBE standards and the open standards. Having unique IDs lets me find things easily as an occupant and say, okay, in my living room, the room is hot. Okay, this is unit 1504 on the 5th floor. If anybody in the audience can even try and find this room, just go to the 5th floor. It's pretty easy, but if you can't, you can try anywhere else. But if you point to this, and you can try other rooms as well too. And that's pretty much it. Then you hit submit. You put your email address in and you'll get a response and say, we're working on it. So this is the occupant saying, send me somebody to fix this. Okay, got the request went in. Okay, now the technician gets a request that comes in as an email. So that's basically it. That's why it's pretty much zero training. It's just 1, 2, 3, just like you use your mobile device, just like you call an Uber, same type of interface. Okay, so let's go back to the slides. Actually, before we do that, let me just show you the technician view. I got an email to the tech, and I'm switching hats here. You're a technician, you got a request that the room is hot. Okay, I'm going to open it up as a technician. Same data, different view, because I'm a technician now. The technician has additional information that they can see in the model. They have information about who sent it in. I can communicate back and say, we're on our way. I can get more information from that and start reacting to it. We won't go into the details of this. There's a lot more to this, but basically a technician can start communicating and finding the air handling unit and finding that additional attributes that came from Collectus and keep on going. Okay, let's keep moving. So we also did some testing as part of this AI BIMStorm. If we have a work order and preventive maintenance system and a digital twin that's reporting stuff that is happening, then you can start asking it in plain English, what's going on with these 50,000 work orders that we've had for the last year? Which systems are failing? Which buildings are, what's going on? Where do we need improvement? You can start having a conversation in English rather than in techie or in engineering terms as a executive, for example. How's our portfolio doing? That's the part that's exciting to us. It's not the fact that you can do really cool things with AI and everything. It's the fact that you can now communicate in simple terms with very complex data and still have the other tools if you need them. The last thing that we did is all this data that we showed from the building. From a digital twin perspective, we have it in what's called a BIM server, which means that you can put it on the web, data as an asset that can be used by other applications to create dashboards in real time. So as we're building up the plans or as we're putting another asset into the building, it starts showing up in these dashboards, whether it's in 3D or in lists, or this is a view of the 18 stories of the building, the floors, the square footage, the work orders, the equipment, the data from Collectus that we talked about earlier is in here too, in a completely different application that was built literally in minutes because the backend, the data in the backend was accessible to build on top of, to be able to create an application that is still tied live to everything else that we showed. So I think we're at the end here, but there's a few more announcements. So we use a lot of different tools. We're going to go over these in much more detail at the conference that was mentioned in St. Louis. It's coming up, but there were a lot of tools used. We just want to acknowledge everybody that participated and used their applications. There's a lot more that can be used, and we're going to continue to explore and apply these to actual projects too. Calgary, I could show a little bit if we want to, but maybe we'll skip for this for now. We showed it earlier, so we won't go through it again. There's a model of Calgary with the connected data there.
We got a question. Want to take that?
Yeah, sure. Let's go questions. The last ones are just announcements about the conferences. So yeah, let's take questions.
Let's hold off on that to the very end. So, hi, great presentation. In the ideal world, assuming that the owner will receive the perfect asset information model as per their owner's information requirements, is it easy for the owner to then maintain the model?
Great question. That's a very important question, because if you hand the owner a model that's too complex, let's say you hand a full Revit model that Cyril was talking about earlier, and he mentioned it too. Yeah, you can get a full Revit model packed with everything they use for design and construction, but then you need a Revit expert. It's very valuable data and a very valuable model, but the technician in the field wants to say something's happening with this piece of equipment. They could care less about BIM or digital twin for that matter. They just want to say, where's their handling unit? So the maintenance part, the way that we found that maintenance happens best is if it's happening as things are happening. If a change happens, if a new piece of equipment gets added or it gets serviced, If a renovation happens, for example, contracting the new consultant that's going to renovate that part of the building with a new BIM execution plan that says, we have a building, we want you to renovate it, but we want you to use our data, renovate it, and give it back to us so we can feed it back and maintain our system. That's for the full model. What happens with data, if it's not maintained, it starts to rot. As soon as you say, well, this is a 1-year-old data or 2-year-old data, you don't know which version is correct. So it's important to have what we call the minimum viable BIM or minimum viable digital twin to be able to do that work for that particular use case, and then decide how much detail to put into it. And those decisions can happen at the very beginning with the owner declaring in the BIM execution plan, we want you to design, construct, build this, and give us the data that we can maintain back in this format and nothing else. Some owners are going to want more, some owners are going to want less. It's really the tolerance level and the capacity that they have to maintain. Cyril, maybe you should answer. This is a good question for you.
No, I think you've answered it well, Kimon. I agree that these institutions often don't have BIM experts, but they do have people that are experts with CMMS or GIS or whatever facility management software they're using. So from our perspective, the key is, the first step is to actually get this data out of the models and into whatever systems are being used. And certainly the next step to maintain those models, I think, Kimon, if I recall, there's something within BIMGenie that allows you to take these BIMGenie models and bring them back out as a BIM model too. But
yes,
it's definitely, that's a double-edged sword. But in our mind, the first step is let's take advantage of the data that's inside these models. And once the institution sees the possibility of all this data in these models that are truly data-rich models, again, it's a consistent language across all trades. And if you want to dig into the weeds, we can talk about features within Revit, specifically. But hopefully that answered the question. But there was a question. Go ahead, Mike.
Go ahead, Cyril. Well, before you go on,
okay,
I want to step back on that question and take it from the concept that an owner is going to want to do something, right? And we were so fortunate to have Steve Whiten from Calgary start this presentation or prelude to this, because he said that the city changed its strategy. It required a policy that was different than previously. And that's what owners need to do. And if you're going to be a proactive owner that realizes there's this new explosion of tools that can benefit you if you use them properly, then the owner needs to establish that policy. And if the owner says the information has to be ready for us to use, then they can also acquire the training for them to use it. So that's kind of in an ideal situation. The real world is much messier with buildings that are already up and they don't have their information properly arranged. And you guys are great at meeting that requirement. But from the leadership perspective, the Asset Leadership Network is saying leaders understand what is even possible so you know what to specify.
Right. Absolutely. Yeah, because if you don't ask that question, you're going to get whatever the consultant or the other teams wants to deliver. And from a leadership perspective, if you're a city of Calgary and say, we want to go down to the tree level and manage and maintain trees, then yeah, you need the tree data in there. You don't want every blade of grass, you want the trees. Same thing with the building. It's a lot of it's called Hollywood BIM a lot of times. But if you have, it looks great, looks really sexy and whatever, you have a full-blown model. And yeah, it's in certain situations very important, but for that technician in the field, it's not. It's like having a Ferrari, but you don't have a paved road to go on it, that type of thing. Or you just need a bicycle, you just need to walk. What is the use case? What is that owner's governance and requirements that they have from a business perspective to perform to? And then you then communicate those requirements very specifically to the team that's delivering. And then the owner can check against that. Did we get that asset of that air handling unit with the attribute of the warranty expiration date? Because usually it's not. Most owners are not getting that. They have to go out and manually harvest for a year to go and backtrack and get their assets in order to put them into a CMMS.
Right. There was a question, Mike, about having this BIM data, you know, that it's not going to replace someone physically confirming that the asset has actually been installed. And I would say, imagine that we've taken these models, we've harvested the data, and the person's doing their commissioning of the building itself. And you've got a you know, this database on a handheld device that lists every single asset and physically its location within the model. In my mind, that's the ideal way to confirm what's actually to confirm is that has that asset been installed, and is it in the right place, and is it the right fixture? So I mean, I see a huge benefit to having this data during commissioning, you know, for that need. There was also a question regarding uniformat. Collectus takes master format, all the contents built in master format across all trades, system and type families, and converts it into uniformat and OmniClass. It batch converts it. And we've got a partnership with the CSI. It's an application built inside Collectus. It's quite remarkable. So if there's a need for uniformat or OmniClass, it's already there in Collectus. So just wanted to mention that.
And Mark, Kimon, did you want to add anything on that?
No, I just wanted to do one follow-up on the how do you maintain. I always use Uber as an example. So Uber is maintained in real time because they have real-time information about where their cars and their drivers and the cost of it and the traffic, all is happening in real time. The reason it works is they do not have a detailed 3D model of every car that's on the road. They have the appropriate level of detail for that particular use case, which is a very detailed map and the location and GIS location, and very detailed information about the riders and the drivers and the cars and the availability. So it's that very specific need and very specific use case, but that's a real-time updating of availability of cars in the city, around the world, at a scale that's immense.
Okay, and then go ahead, Cyril.
No, go ahead. I was gonna say, Kimon, if you can talk about how BIM Genie can accept within that structure other file formats like AutoCAD or PDFs or Excel. I think there was a question regarding if it's not BIM, is it still possible to grab, you know, to somehow catalog an existing inventory of buildings, rooms, and assets?
Absolutely. Yeah. In fact, when I showed the community colleges, that's what we started with. They had a list of 90 million square feet of buildings that were not in BIM, but they had a database. We basically we linked through an API to their SQL database and connected all their spaces. So it created little blocks in the plan. Then if there was a PDF, then we put the PDF in. So it's not, you don't have to have it all to the same level. In other words, getting it started and then adding more detail as available. And the spreadsheet is the lowest common denominator, or even a hand sketch for that matter. If you have a hand sketch, here's the first floor, there's 5 classrooms there. But in their case, they actually had very valuable data of the entire state down to the room level, which means, well, let's use that. We don't have to rebuild it. And this is a pattern that we've seen over and over again with other owners as well. You can start with whatever you have.
Yep. What I find interesting, Kimon, is that in this example you're showing, the state has one level of information, the city has one level of information, each campus has their level of information, and the individual buildings have their level of information, none of which is accessible by you, none of which is editable by your team, and yet they can visualize everything all at once in real time and go from the macro to the micro very quickly. And again,
yeah,
and there's no mechanism to edit any of that stuff on your end. They're managing all of that.
Yeah.
So I think that's
right.
Quite exciting.
Yeah, it's a governance and asset leadership role to say who owns that piece of data and who can edit it, who can see it, who can update it, who can export it. You can get as granular as that if you have it in a modern system that can feed the data like that. So that's if you have it in a database, then you can make those rules up, and it can change on the fly. You can say, well, next year we're going to change our rules and dial it up or down. Do we allow students, for example, to see the name of the classroom? Why not? Do we allow students to change the name of an asset? Absolutely not. Do we allow them to see the asset? Absolutely not. The technician, yeah, they can see the asset, they can see the floor, they can see it. If the technician no longer works for the community college, you turn that switch off and they don't have access to it. So it's that permission and security level at a granular scale, and then anything's really possible after that.
And of course, having first responders access that data too. is
Mhm.
incredibly powerful.
Okay, two questions, and you've kind of addressed them already, but since there's a question, there's a need for clarification. And one is that the models look standardized. Is there a level for creativity? So I think what I might be able to address this in that there was a program for a corporate apartment building in that empty space in Tokyo. So
Mhm.
the owner expressed the requirement. Then you used the ONUMA system to establish number of floors, space layout, and it was a quick design. Then you imported that into artificial intelligence and it created a curvy building, right? So I think that addresses the question for Mark DeClercq. Is that no?
Kind of, yeah, that's good. That's a good start. Let me add a few more things there.
Sure.
Even without all these tools, when we start with architects, and we say, here's a program requirement for spaces for this. These are classrooms that you're seeing here. These are the classroom sizes. It doesn't mean that your final design is going to look like. You still can say, well, we're going to make a Zaha Hadid style College of AI, and we're going to take that and put it in there. That's still valid. The difference is that you can still trace it back to the owner's requirements. Then it's up to the architects and engineers to become creative. Do we make it curvy? Do we add more? Is there something missing, which Cyril actually mentioned, right? This is not a perfect design to begin with. It's getting there quicker. And I know for a fact when you do this manually, because I used to do this years ago, when you do it manually, try and collect all this data, you could spend months just trying to get the right information just to start the project. In this case, it could happen in minutes if you have the right data and the right, but it doesn't limit your design and actually enables you to explore more, to be more creative with it, knowing that the data is valid.
Can you show the high rise that's curved? Because I know that that's a direct variation of the very massing model version. All right, so this is how it explains it. It starts out, it looks like a massing model, but you can expand on that design.
That's right. Yeah,
Okay.
we started, this is the actual massing. This is AI saying, let's render the top of this, very similar to that. Then we said, what if we put some curves, curve the upper floors, for example? What is it going to look like? This is not adjusting the original model. The designer still has to resolve it. And there are tools to start automating some of this too. That's the other part that's pretty exciting if you think in terms of all these different tools that are out there. And then we said, okay, let's do a detailed rendering at the top. This is AI generating something that's pretty close. It's surprising how close it can get, but it's not the final design, and it definitely needs to be vetted, and it definitely makes mistakes, absolutely makes mistakes. And that's where the designers and engineers have to step in. Just like you're working with a junior designer, you don't just let them go for a month and say, okay, you're done. You're having a conversation, which is the same that's we're having here. We're
So I think that addresses that. Yeah, much faster. And Amanda asks if you can speak to how owners who have existing inventory of buildings can utilize these tools. I think you answered that with the California Community College example. So let's go on to Joe's question about, do you see maintenance of BIM, GIS, digital twins, similar to the evolution of municipal GIS systems?
Yes.
Where owners will outsource the curation, maintenance, and driving policies for their digital tool portfolio?
It varies by the owner. Maybe Cyril, you might have a better answer for this, but yeah,
No.
I think it varies by the owner. But
Yeah, I think that for those owners that are currently using GIS for the exterior of their building, they have indoor GIS. That's a whole nother world of being able to maintain those assets and maintain those buildings. I mean, in my mind, GIS is so far beyond what BIM can provide in terms of maintaining, an entire campus and to be able to locate the building, the level, the room, the asset very quickly. I think indoor GIS is to me, and this is what BIM Genie is doing. But that to me is the best way of managing, a physical building or a campus. I'll give you an example.
Go ahead.
No, there was a client that had. They said there was a water main break And for 4 hours, they couldn't locate the shutoff, and the water was leaking into a library and caused all kinds of crazy damage. In a geodatabase, you could go to a map, show me the shutoffs. In literally in seconds, you can find where the shutoffs are, which rooms they're in, what they service. I mean, the possibilities just for indoor GIS for shutoffs of power, water, and gas is priceless. So I'll step back to Kimon.
All right, let me quickly address that in a more big picture. Yes, business processes are going to change. What an architect provides, what an engineer provides, what the concept of service is going to change dramatically. And the companies that jump on this and understand how to use these tools and understand how to offer these services, of course. So in the home building industry, home builders used to build homes and sell them. Now they realize, oh my goodness, that's 20 years of mowing the lawn. We can make more money if we offer lawn maintenance service to the person who bought the home from us. They trust us. Why don't we set up and mow their lawns? Why don't we wash their windows? And so this is giving an opportunity for people to do things differently. So Joe, we want to be having a web program with you, Joe, when you are showing how you have taken this service to an owner. So Kimon, will you wrap it up by showing what's coming up?
Yeah, what's coming up? August 1st through 4th, St. Louis, Campus FM Technology Conference. Cyril and I are going to be presenting, and Mike, I think you might be there too, maybe?
Yes.
Okay. Asset leadership. You can explain this one. Go ahead.
So we're very happy to be Kimon is very generously rebranding BIMStorms to AI Brainstorms. And the ALN is focusing on specific industries. And the first industry we're going to focus on is ports industry. And Trent Port Services, which is an ALN member, is going to be our owner representative. And Cyril and Kimon are going to be showing how these types of services and information management will be applied in the ports industry to transform it. And if you would like to become an ALN member and work with Kimon and Trent Port Services and Cyril in developing this, we really welcome that. And then we'll have the presentation on August 17th. And then we'll have Tree Storm after that. And then in January, we're going to have Federal Storm to show how this AI and digital twins governed by asset management can address federal issues.
Right. And then we just found out yesterday, actually, that I'm going to be presenting at the National Institute of Building Sciences annual conference, the Building Innovation Conference. The topic is Intersection of AI and Building Sciences, a New Era of Intelligent Infrastructure. I'll be presenting with Roger Grant and Jay Klein of NIBS. This is in September 5th through 7th. And then we have a whole series of other presentations that Cyril's also involved with. So we talked about August and September. Cyril, jump in here. October, what's happening? Oh, October and March. I actually got the right date on the right wrong, but go ahead.
Right. No, these are trade shows. We'll be both Kimon and I will be presenting at these different trade shows, and both Tradeline in October. I guess that's in Boston, and then NFMT next year in Baltimore. So very excited about that.
Great. And we ran a little bit over, but acknowledgement of all the tools that were used, participants over the last few months in the AI BIMStorms we learned from each other, and ALN helping to push us along and keep us innovating.
Right.
Well, thank you, Kimon. Thank you, Cyril. And thank you to all of our attendees. And I really appreciate your interest and questions that just keep on coming in. Oh, they're thanking us. It's not a question. And I really appreciate this. It's exciting to be working with these people who are so passionate and to have the audience that's equally passionate. We really appreciate it. Thank you. And we look forward to seeing you again in the future.
Thank you.
Thank you. Thank you.
Bye for now.